sklearn, covariance, empirical covariance. Description. The empirical covariance function calculates the empirical covariance matrix of a dataset. It assumes that the data points are independent and identically distributed I.D. The covariance matrix measures the linear relationship between pairs of variables in the dataset. Inputs: X a 2D array-like data structure, where each row represents a data point and each column represents a feature. Outputs: Cov a 2D array representing the empirical covariance matrix. The shape of the covariance matrix is n features. N features, where n features is the number of features in the dataset. Steps: The function first calculates the mean of each feature in the data. It then subtracts the mean from each data point, resulting in a centered dataset. Finally, it computes the dot product of the transposed centered data with itself, and divides the result by n samples 1, where n samples is the number of data points. Metrics: None. Visualization plots. Heat map of the covariance matrix visualizes the relationships between pairs of features. Scatter plots of feature pairs shows the distribution of data points for different feature pairs. Fine-tune parameters. None. Uncertainty methods. Bootstrap resampling repeatedly samples data with replacement and calculates the covariance matrix for each sample. The distribution of covariance matrices can be used to estimate uncertainty. Challenges and fixes. Challenge 1: High dimensionality. When the number of features is large, the covariance matrix can become difficult to estimate accurately. Sample use case that resulted in challenge 1: A dataset with thousands of features. Fixes to challenge 1. Use regularization techniques like Leduit-Wolf shrinkage or graphical lasso to estimate the covariance matrix in a more robust way. Consider using dimensionality reduction techniques like principal component analysis (PCA) to reduce the number of features before computing the covariance matrix. Challenge 2: Outliers. Outliers can significantly distort the covariance matrix. Sample use case that resulted in challenge 2: A dataset with a few data points that are far from the rest. Fixes to challenge 2. Remove outliers before computing the covariance matrix. Use robust estimators like the minimum covariance determinant (MCD) estimator. Challenge 3: Missing data. If the dataset has missing data, it can lead to biased estimates of the covariance matrix. Sample use case that resulted in challenge 3: A dataset with missing values in some of the features. Fixes to challenge 3. Impute the missing values using methods like mean imputation or k-nearest neighbors (KNN). Imputation. Use methods that are designed to handle missing data, such as the pairwise complete correlation estimator. Challenge 4: Nonlinear relationships. The covariance matrix only captures linear relationships between features. Sample use case that resulted in challenge 4: A dataset with nonlinear relationships between features. Fixes to challenge 4. Use nonlinear methods like kernel methods or neural networks to capture the relationships between features. Consider using alternative measures of dependence like mutual information.